Alright, time to do one more video on solving trigonometric equations by factoring. I see that both terms have cosine in it, so I can factor out cosine because it is the greatest common factor. So I'm going to bring cosine outside of parentheses. That's going to leave on the inside 2 cosine x minus radical 3. Now it's time to set both of these equal to 0. So cosine x equals 0 and 2 cosine x minus radical 3 equals 0. This one is already isolated, but this one needs a little bit of work. So I'm going to add radical 3 to both sides. Now I have 2 cosine x equals radical 3, and then now I will divide both sides by 2 to get cosine all by itself. So now I've got cosine x is equal to radical 3 over 2. Now let's look at both of these. The cosine of what angle is 0? Well, looking at our unit circle, and remembering that cosine is the x value on a unit circle, where is the x value going to be 0? The x value is going to be 0 on the y-axis. So the x value is going to be 0 here and here. Okay, so that's pi over 2 and 3 pi over 2. So those are two solutions right there. So x is equal to pi over 2 and 3 pi over 2. Now, where is cosine equal to radical 3 over 2? Cosine of what angle? Well, let's start with the reference angle. Let's look at this chart of things you're supposed to memorize. Here's cosine, here's radical 3 over 2. Cosine of pi over 6 is radical 3 over 2. All of this needs to be memorized. So the reference angle is pi over 6. So when I draw my unit circle, I'm going to draw it with pi over 6's showing. Okay, so here is my unit circle. Alright, here's pi up top. So I need to divide that into 6 pieces. And I hope you'll forgive my crooked lines, but writing with an electronic pen is not as easy as you might think. Whoa, that's a bad one. Okay, so here in the top you see I have 6 pieces. Each one of them represents pi over 6. Now specifically, these 4 angles have a reference angle of pi over 6. Alright, they are the angles immediately above and below the horizontal axis. So they all have a reference angle of pi over 6. That means the cosine of any one of these angles is going to give me some kind of radical 3 over 2. It's just that 2 of them will be positive and 2 of them will be negative. Now, which is which? Well, again, remember that cosine on the unit circle is the x value of each point. So imagine the x-axis. We know that positive x values are on the right-hand side and negative x values are to the left. That's why the cosine will be positive over here on the right and negative over here on the left. Now for this particular problem, we want a positive radical 3 over 2. So that means that these are the 2 angles that will be the solutions. So what are they? So remember, these are pi over 6's, so this first one is simply pi over 6. So I'll add that to my list. The second one Well, I could count all the way around and go, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6 is what this is. But that was a lot of counting. So it'll go a little bit quicker if you use shortcuts. For example, remembering that 2 pi, all the way around is 2 pi. That would be the same thing as 12 pi over 6. So if you take away 1, then that's 11 pi over 6, a little quicker. Anyway, that's it. So that's going to be the answer to this problem. We have these 4 answers. So we need 0 on one side, so let's go ahead and subtract 1 from both sides. So that's going to give us 2 sine squared x plus sine x minus 1 is equal to 0. So this is probably factorable. 2 sine squared x could factor as 2 sine x times sine x. Alright, that would give you, if you multiply these, you would get 2 sine squared x. Now, skip the middle and look at the negative 1. Actually, ignore the negative sign even. Just consider the number 1. You can only get 1 by doing 1 times 1. So let's go with that for now. Now here's the key to the Burton method. Inner plus outer must equal the middle. Now inner, I'm talking about these two. That's 1 times the sine of x. Outer, that's these. That'll be 2 sine x. Now when I say inner plus outer equals middle, this is the middle term that we are shooting for. So how can I get these like terms to add up to positive sine x? Alright, this is sort of like having positive 1 sine x. So if this were negative 1 and this were a positive 2, that would combine to make positive 1. So that's what we need. So that means this has to be negative and this has to be positive. Alright, to make negative 1 and positive 2, inner and outer. And check one more thing. This third term, remember it was negative 1. And here we would have negative 1 times positive 1. That will give you a negative 1. So that was important that that works out as well. So we factored it. Now, to solve this equation, we need to set both of these equal to 0. So we will take 2 sine x minus 1, set that equal to 0, and we will take sine x plus 1 and set that equal to 0. So to solve this, of course, I'm going to add 1 to both sides. So now I have 2 sine x equals 1. And got to get rid of that 2 by dividing both sides by 2. So now I have sine x equals 1/2. Now meanwhile over here I'm going to subtract 1 from both sides, so that gives me sine x is equal to negative 1. So the sine of what angle is equal to 1/2? Let's look at that chart of things that we're supposed to memorize. This will help us know the reference angle. So here's sine, here's 1/2. So the sine of pi over 6 is 1/2. Now that's not necessarily the answer, but that gives us the reference angle. So the reference angle is pi over 6. So I'm going to draw a unit circle showing a bunch of pi over 6's. Okay, the top half is pi, so I'm going to divide that into 6 pieces. Alright, which is a little tricky with this electronic pen, so forgive me for these crooked lines. Alright, so up here you see I have 6 pieces, So each one of these is pi over 6. Now, focus on the 4 angles that have a reference angle of pi over 6. Those will be the 2 angles immediately above the horizontal and the 2 angles immediately below the horizontal. Alright, all 4 of these angles have a reference angle of pi over 6. That means the sine of any of these angles will give me some kind of 1/2. It's just that 2 of them will be positive and 2 will be negative. Now, how do I know which are positive and which are negative? Well, remember that on the unit circle, the sine is a y value. So look at this y-axis here. Y values are positive above the x-axis, and they are negative below the x-axis. That's why these 2 angles will give us a positive sine because they're above the x-axis. And these 2 angles will give us a negative sine, where the y values are negative below the x-axis. For this particular problem, we want a positive 1/2. So these are the 2 angles that will give us a positive 1/2. So what are these? So this first one is pi over 6, alright, because it's just 1 pi over 6. And then it goes 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay, so there are 2 solutions so far. So we have pi over 6 and 5 pi over 6. Now, look at the next one. Sine of x equals -1. So sine of what angle is going to equal -1? Well, let me draw another unit circle real quick. Okay, this one will be much simpler. So remember, on the unit circle, sine is the y value. So where on the unit circle will the y value equal -1? Well, way up top, the y value is 1 because it's up 1. Way down here at the bottom, the y value is -1 because it's 1 down. Alright, so that's it. This is the angle where the sine of this angle is -1. So what is this angle? Well, each one of these quadrants is pi over 2. So this is 1 pi over 2, 2 pi over 2, and this is 3 pi over 2. So that's another solution. Got to add that to the list. 3 pi over 2. Alright, so that is it for number 27. Okay, one more. This will be the last problem, number 28. Alright, I'm noticing that we have tangent here twice in both terms. So we can factor that out. Tangent x is the GCF, it's the greatest common factor. So if I pull out tangent x, inside the parentheses I will have cosecant x minus 2. That's my wife's ringtone. Now it is time to set these two factors equal to 0. So tangent x equals 0 and cosecant x minus 2 equals 0. Now this one I'm going to add 2 to both sides. So that'll give me cosecant x is equal to 2. Now the thing about cosecant is that cosecant is the reciprocal of the sine function. So the reciprocal of cosecant is equal to sine. So if I do the reciprocal of both sides of this equation, the reciprocal of cosecant will be the sine function, and the reciprocal of 2, of course, is 1/2. So this is the function I am more familiar with, so I am going to do the reciprocal and use the sine function instead. Alright, I just brought that down. So now let's look at these and answer these questions. Tangent of what function equals 0? Now, okay, remember that tangent of an angle is equal to sine over cosine. Okay, the only way that tangent is going to equal 0 is if the numerator equals 0. Alright, that's the only way. The denominator can't be 0 because that would be undefined. So the only way you're going to get 0 for an answer is if the numerator equals 0. So this equation will have the same solutions as this equation. Okay, tangent will be 0 only where the sine function equals 0. So this will be easier to deal with. So let's go ahead and look at this instead of this. Now, looking at the unit circle, when we ask ourselves sine of what angle is equal to 0. Now remember that on the unit circle, the sine function is the x value of, the sine function is the y value of every point, the y value. So where is the y value equal to 0? The y value equals 0 right on the x-axis. So the y value will be 0 here and here. So that means the sine will be 0 in these two angles. So that's why from this equation I get two solutions, 0, that's this, and pi. Okay, now let's look at this one. Where is sine equal to 1/2? Well, let's look at the chart of things that we are supposed to memorize. Here's sine, here's 1/2. Pi over 6. So the sine of pi over 6 is 1/2. Memorize that. That doesn't mean the answer is pi over 6. That just means that the reference angle is pi over 6. So the way I handle that is I will draw a picture showing a bunch of the reference angle. Wow, that's a horrible circle. Let me try that again. I think I can draw a really good circle if I just go like this. Cheat, 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 cheat. Oh my goodness, that's a perfect circle. Let's see, can I change the color of it? That's interesting. Uh-oh. Alright, this program will do the rest of this video. So I'm going to draw a bunch of pi over 6's. So this is pi up top. So if I split this into 6 parts, alright, just focusing on the top half, then that will be pi over 6. So I'm going to go like this, and I'm going to go like this. Alright, this is really tricky to do with an electric pen, but I'm going to do my best. I am not an artist, as you can plainly see. So in the top half I have 6 parts. So each one of these is in fact pi over 6. Okay, what of it? So there are 4 angles that have a reference angle of pi over 6. Those will be here, 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 and here, directly above and below the horizontal x-axis. So the significance of that is the sine of any of these 4 angles is going to give me some kind of 1/2. It's just that 2 of them will be positive and 2 of them will be negative. Now remembering that sine is the y value of every point on the unit circle, and think about y values. See, this is the y-axis. Y values are positive above the x-axis and negative below the x-axis. That's why sine will be positive here and here above the x-axis, and negative here and here below the x-axis. Now in this particular case we want the sine to be positive 1/2. So these are the 2 angles that will give us the solution that we want. All right, so what are these? Well, each one of these marks represents pi over 6. So this is simply pi over 6. Okay, 1 pi over 6. I'll add that to my list. What about this one? 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So we'll add that to my list. So these are the 4 solutions to this equation.